This is the question from NET-JRF 2019. This is question number 22. In this question it is given that a turntable is rotating with constant angular velocity omega 0 in the rotating frame. Fixed to the turntable, a particle moves radially outwards at a constant velocity v0. The acceleration of the particle in the r theta coordinate as seen from an inertial frame, the origin of which is at the center of the turntable, is option A minus r omega square r cap, option B 2 r omega square r cap plus v naught omega naught theta cap, option C r omega square r cap plus 2 v naught omega naught theta cap, option D equal to minus r omega square r cap plus 2 v naught omega naught theta cap. For solving this question, as you know, the acceleration in polar coordinate can be expressed in the form A equal to ar r cap plus a theta theta cap, which is equal to, now ar is equal to r double dot minus r theta dot square, and its direction is equal to r cap plus, and a theta is equal to r theta double dot plus 2 r dot theta dot, and its direction is theta cap. Or this A acceleration vector can be written in the form of d2r with respect to dt square minus r d theta with respect to dt, with direction vector r cap plus r d2 theta with respect to dt square plus 2 dr with respect to dt multiplied by d theta with respect to dt, with its direction vector theta cap. Now from the given condition, from the conditions of our question, it is given that the linear velocity means dr with respect to linear velocity dr with respect to dt, which is equal to r dot, is equal to v naught, which is a constant. Now we can write d2r with respect to dt square will be equal to d dt of a constant. Now as the constant of a derivative of constant term is equal to 0, therefore we can write r dot is equal to v naught and r double dot is equal to 0. Again, the angular velocity is given as d theta with respect to dt is equal to theta cap, which is given in our question as omega naught. And if we derivative this again, then we'll get d2 theta with respect to dt square, which is equal to theta double dot, which is equal to d dt of a constant, because omega naught equal to constant is a constant which will be equal to 0. Therefore we can write our theta dot is equal to omega naught and theta double dot is equal to 0. Now we'll substitute the value of this expression into our acceleration term. So if we substitute these terms, then we'll get our acceleration term will become, instead of r double dot we will replace 0, and instead of theta dot will replace omega naught. Then it will become r omega naught square, and its direction vector is equal to r cap plus, instead of theta double dot will replace 0, then it will become r into 0 plus 2, instead of r dot will replace v naught, and instead of theta dot will replace omega naught, and its direction is theta cap. Therefore, we can write the final expression of finding the acceleration. A will be equal to minus r omega naught square r cap plus 2 v naught omega naught theta cap. So this is our desired result, which is matching with our option D. Therefore, we can write our correct option is option D. So option D is correct option. Is correct.